So on the infinitely many case, I'm assuming you guys rearranged these a little bit before you tried to stuff it in an augmented matrix, right?
Sure.
Ish. You didn't necessarily have to, right? So after you rearranged, in order to stuff it into an augmented matrix, probably ended up with -1 from the x coefficient here, 1 from the y coefficient augmented by 2. Everybody? Okay, what was your second row? Cool. Okay, then you ref this, and what you ended up with looks like 1, -1, -2. And all zeros. Okay, so how did I know that this should be a -2?
Take a look at the board.
Yeah, if you take a look at the board right here, right?
Well, that was the.
In order to get to 1 and -1, that is just the first equation multiplied by -1, right? And we already talked about this thing as being one line written down twice. So all the row reduction step in the calculator is doing on this one is it's multiplying this row by 2, adding that to this row. It's getting a row of all zeros. And then it's like, well, but I want a 1 here, so I'm going to multiply that row through by -1. We're going to go through that algorithm really carefully, step by step, in a couple of days. If you know it already, you're like, oh yeah, of course, that's what you end up with. If you don't know it yet, the calculator's doing something, right? Those steps are understandable. We can figure out what those steps are. They don't have to be a black box anymore. What did you guys get after you row reduced this second one? You see that? Okay. And after the third one, what did you get?
1, -1, 0. 0, 0, 1.
Okay. So let's read these here tea leaves. On this one, the bottom equation reads what?
0 = 0.
Good. On this one, the bottom equation reads 0 = 0. That is true. 0 is 0.
Yes.
Check. Right? Like the top equation says something, right? The top equation says x minus y equals -2. But the bottom equation just says like, yeah. Right? Which is why this thing ends up with infinitely many solutions. Because that second equation really isn't contributing anything. Which we saw way back in the algebra, right? You guys all saw that as soon as I wrote this equation down. So here in the one solution case, we were refed. Top equation says x is 0. Bottom equation says y is 0. That means 0, 0 is my one solution. Cool. On this guy, that's a little harder to read. What does that bottom equation say?
Nonsense. 0 = 1.
Nonsense.
Yeah, it says 0 = 1. And that just ain't the case, right? Like no matter what x and y are, that ain't gonna work out for me.
Not quite.
Right? So that's why this one ends up with no solutions. You guys see that? Okay. You guys are probably far enough along in math to understand this, but sometimes there's a confusion over no solutions is like a problem or somehow bad. Is that the case? No, there are lots of things for which I want there to be no solutions, right? When I ask questions like, when do we run out of food? I'm really hoping the answer is no solution. Right? You guys see that? Like, when is everybody dead of the plague? Fuck, I really hope that one doesn't have a solution, right? Because if the answer is like, T is tomorrow, I'm like, fine, whatever. Does that all make sense?
Yeah.
Okay, so don't get attached to some like moral interpretation of these. They just mean something in the math. The infinitely many solutions, that does sometimes occur in data. Usually what that means in a data sense is that you're talking about the same variable twice. That happens when you do something like input into your database the customer's shoe size in American and the customer's shoe size in European. Right? Like, those are the same freaking data. They don't represent two different things. They're two numbers, right? They're going to help me when I buy different kinds of shoes, but there's an easy conversion between them. You guys see that?